Alright, let's talk Python classes. So, if you're learning Python, if there is a topic that you can skip, it's classes. So, if terms like self, inheritance, object-oriented programming, polymorphism, operator overloading ever confuse you, then you're in the right place. So welcome to this in-depth course on Python classes. Now, classes are a deep topic, and while we won't cover absolutely everything in this 2 hours course, what I've done is that I've structured this course to give you a strong, solid foundation that you can build on. Now, this video that you're about to watch is structured into chapters, so feel free to navigate to whatever section that you want, okay? Or you can just watch the whole thing from start to finish. So, before we start writing code, okay, I have one more favor to ask from you. If you find this helpful, if you learned something from this video, make sure to like the video and subscribe to the channel. It really helps more people find this content. So, it's time to talk about classes. Let's get into it.
Now, let's talk about object-oriented programming. So Python is an object-oriented programming language. So what does that mean? So it means that everything in Python is an object. It is an object that belongs to a class. So for example, let's say we create a variable here called myNumber, and we give it a value of 7. So this is an object. If we check the type of class that this object belongs to, if we run this code, we get this int class or the integer class. So myNumber is an object that belongs to the integer class. So that's what it means basically. Everything in Python is an object that belongs to a class. So this integer class provides methods. So methods are basically functions that support operations that can be performed on objects that belong to the integer class. So we can call these functions on this integer object. So for example, if we check the type of methods that belong to the integer class, we run this code. So all these methods here are methods or functions that belong to the integer class. And we can call these methods on the objects that belong to the integer class. So for example, let's say we have two numbers here. Let's say we have another number. Okay, and we give it a value, let's say 5. If we want to add these two numbers, we can call this add method on this object. So for example, we can say print myNumber dot add and give it another number. If we run this code, what we get? We get 12. So methods are basically functions. These functions allow us to perform operations on objects that belong to that class. So we are able to add two numbers together because the integer class provides this add method. So even when we do something like num1 plus another number, for this operation to be successful behind the scenes, the add method is invoked, and that makes it possible for us to be able to add these two numbers together. So myNumber is an object that belongs to the integer class. If we create, let's say we create a string here. Let's say my string. We give it a value, let's say hello. If we check the type of class that this object belongs to, to run this code, you can see that it belongs to the string class. So the string class provides methods or functions that we can perform on this object that we have created that belongs to the string class. So for example, we have already seen how we can call the upper method, for example, to convert the string to uppercase letters, like we've done here. So this upper method is a method that belongs to the string class, and we can use it on objects that belong to that class. If we create a list here, let's say my list, and let's say we have two numbers in this list. If we check the type of my list here, we get list class. So this object that we've created here, this my list object, belongs to the list class. And this list class provides methods that support objects that belong to the class. So for example, we can check the length of this list because the list class provides the length method. If we check here the method that are provided by the list class, you can see that one of the method is the length method, this one here. So we can call this length method on a list object. So for example, if we wanted to check the length of this of my list, this object that we've created here, we can say my list dot length. Run this code. You can see that we get 2 because we have 2 items in this list. So we are able to check the length of this object because the list class provides the length function. So even when you do something like length my list, the list method, the length method gets invoked. Every time you do something like this to check the length of an object that belongs to the list class, the length function or the length method gets invoked. So these are just a few examples of what objects are and the classes that they belong to. Now, in Python, we can also create our own classes. So let's look at how we can create our own objects in Python in the next video. Now, we can create our own objects in Python, and Python provides a blueprint that we can use to create objects. So to create objects in Python, we use the keyword class. So after class comes the name of the class. So let's say, for example, we want to create a class about cars. So we are going to give this class a name called cars, just like that. Now, a class is not an object. A class is simply a blueprint for creating objects. So when we create objects, these objects are going to belong to this class. So how do we create objects? So to create an object, we simply call this class and assign it to a variable. So we can say, for example, BMW cars, just like that. Now, this process of creating objects that belong to a class is also known as instantiation. So this BMW that we have created here is an instance of this cars class. It is an object that belongs to this cars class. So this cars class is not an object, but this BMW here is an object. Now, we can add features to this class. So these features represent characteristics that we expect these objects that belong to this class to have. So let's say, for example, we expect that all these cars that we're going to add to this class will have 4 wheels. So we are going to create a variable here called number of wheels and give it a value of 4. So this variable that we have created here that represents a characteristic that the cars that belong to this class will have is known as a class attribute. This is because we have defined this variable inside of this class. So the objects that we are going to create, or the objects that belong to this class, will have access to this class attribute. So for example, here we have created an object called BMW. So if we want to know how many wheels this BMW has, all we have to do is use the dot notation. So we call BMW dot number of wheels. If we print this, you can see that we get 4 here. So this car, this BMW, this object that belongs to this cars class has this attribute. It has 4 wheels. Now, when you create a class like we have here, we can add as many objects as we want. So let's create another object here. Let's call this one Honda, just like that. So this Honda object that we have created has access to this class attribute. It also has 4 wheels. If we want to access or check how many wheels this Honda has, all we have to do is say Honda dot number of wheels. Just like that. If we run this code, you can see that this Honda has 4 wheels. Now, a class can have attributes, like we have an attribute here, but it can also have methods. So methods are simply functions. Functions that will support operations that will be performed on these objects that we have created here, these instances of the class. So to create a method of this class, we use the keyword def. This is because methods are just functions. So we use the keyword def and we give this method a name. Let's say, for example, we want to create a method that will start a car. So we're going to give this method the name start car. And we want this method to return car has started. So this method here will be used by the objects that belong to this class. So, for example, we can use this method on the BMW by calling it using the dot notation. We can say BMW dot start car. When we run this code, we get car has started. So because this method that we've created here is used to perform operations on these objects or these instances that belong to this class, this method is known as an instance method. This is an instance method. Now, you may have observed that the first parameter that has been passed to this method is called self. We're going to talk about self in the next video. But all you have to know for now is that this method here is a method that will be used on these objects that we have created here. So because it's being used on these objects here, it is known as an instance method. And in a class, we can have as many methods as we want. So for example, we can create another method here called stop car. And we want this method to return car has stopped. So all these objects that we have created here, the 2 objects that we have created here, will have access to these methods. So we can use this stop car method, for example, on the Honda car that we've created here. So we'll say Honda dot stop car. If we run this code, what we get car has stopped. So both of these methods are known as instance methods because these methods are used to perform operations on these objects that we have created. Now, these objects that we have created here have one common attribute. They all have 4 wheels. But what happens if we want to assign different attributes to these cars, for example? So, for example, this BMW will have a different color from this Honda car. These cars will have certain features about them that will be different. How do we assign different features to these objects? We're going to look at that in the next video. Welcome back. Now, these two cars that we've created here, or these two objects that we've created here, they have one common feature or one common attribute. They all have 4 wheels. Okay? That's a common attribute. They all have 4 wheels. Now, there are certain attributes about these cars that are different or that are unique for each car. Color is unique for each car. Mileage is unique for each car. So how do we assign unique attributes to each of these objects that we've created here? So to assign unique attributes, we use a special method. So this method is known as the init method. So we need to define these attributes inside of this method. So we're going to define this init method, and then inside of this parenthesis, we're going to pass it the values that we want each of these objects to have. We're going to pass these values as parameters to this method. So let's say we want each car here to have a unique color. So we'll pass color here. And if we want, let's say, mileage, we'll pass mileage here. Now, we have passed color and mileage as parameters. So this means that when we create objects that belong to this class, to this cars class, we'll need to pass values for color and for mileage. Now, you may have noticed that the first parameter here is self. So we have 3 parameters here. We have self, we have color, and we have mileage. So when we when we create an object that belongs to this class, we'll pass it value for color and we'll pass it value for mileage. But where is the value for self going to come from? Well, the self here refers to the objects, the actual objects that we are going to create. So when we create an object here, for example, we have created BMW here as an object. This BMW is passed as an argument to this self parameter. That's how Python works. So here we've created a Honda as an object. So this Honda is passed as an argument to the self parameter. So the self here is referring to the objects, the instances of this class. Now, we need to assign this color and mileage to variables. So we can say color equals color and mileage, just like that. Now, these attributes that we are creating here will belong to the instances of this class, these objects that we are creating for this class. Now, for these objects here to interact with these attributes here, we need to bind each of these objects or each of these attributes with self. Remember, self refers to the objects. So we are going to prefix color here with self, just like that. And mileage with self. So the self here is simply an object. So when we create an object here like a BMW, all you can do is just replace the self here with BMW. If we create an object, let's say Honda here, all you have to do is replace this self here with Honda. So now that we have defined these attributes here, when we are creating objects, we need to pass arguments for color and mileage. So let's change this here. Let's add features. Let's add these arguments to this BMW object that we've created here. So the first argument that we're going to pass is color. So let's say the color of this BMW is black. And the mileage is, let's say, 10,000 miles. Just like that. And for this Honda, this other object, let's say the color is white. And the mileage, let's say, is 150,000 miles. So now, when we create objects, this black here has been passed as an argument to this color parameter. And this 10,000 miles here to this mileage parameter. And then this BMW has been passed as an argument to this self parameter. So if we want to check how many miles a BMW has, all we have to do is BMW and then use the dot notation, say miles or mileage, just like that. If we print mileage here, if we run this code, you can see that the BMW has 10,000 miles. If we wanted to check the color, we'll do the same. And this time around, we'll say BMW dot color. If we run this code, we get black. So we can do the same for Honda and any other objects that we are going to have to this class. Remember, you can add as many objects as you want. Now, what does this init method do? So, when you create an object, like we have created an object here, okay, called BMW, and I've assigned it these values, black and mileage 10,000, Python invokes this init method. And then the init method will assign these values to the parameters that we've passed here. So it will assign black to color and 10,000 miles to this mileage parameter. That's what the init method does. So these attributes that we have created inside of this method here, they are known as instance attributes. This is because these attributes here belong to the instances of this class, to the objects of this class. That's why they are known as instance attributes. This attribute that we've created outside of a method is known as a class attribute. This is because this attribute here belongs to the class. Okay? Any attribute that is defined outside of a method is known as a class attribute. Attributes that are defined inside of a method, like we've done here, these are known as instance attributes. Welcome back. Now, let's talk about class attributes and instance attributes. First, let's talk about class attributes. So class attributes are defined, obviously, inside of a class, but outside of this init method. So class attributes do not belong to a specific instance. They belong to the class and they are shared among all the objects that belong to this class. So for example, if we check here the number of wheels that, let's say, BMW has, okay, BMW dot number of wheels, you can see that we get 4. So since this number of wheels attribute is shared among all the objects or all the instances of this class, we can do the same for Honda. We can say Honda dot number of wheels, and you can see that we also get 4. So this class attribute is shared among all the objects that belong to this class. It doesn't belong to a specific object. It belongs to the class. It's been defined outside of this method. So it is shared among all the objects that belong to this class. Can we modify this class attribute? Yes, we can. And there are 2 methods that we can use to modify this class attribute. We can modify it by accessing it as a property of the class. We can access it outside of this class as a property of the class and then assign it a new value. For example, we can say cars dot number of wheels, just like that, and then assign it a new value. Let's say 8 wheels. When we do this, it means that the number of wheels for both of these cars is going to change from 4, which was the initial value, to the new value of 8. If we run this code, you can see now that we get 8. The number of wheels for both BMW and Honda has changed. Okay, so it changes for both of these cars because this class attribute is shared among all the objects that belong to this class. Now, we can also modify this class attribute inside of an instance method. So, for example, we can use the startCar method to change the number of wheels here. So first, we need to access it. So we access it using as a property of the cars class. So we say cars dot number of wheels, and we can assign it a new value. Let's say 10. Okay. Another way we can access this is using self, like this. This will do the same thing. Now, if we call this start car method, let's call it on BMW. Okay, let's call it on BMW. So we'll say BMW.startCar method, just like that. Now, when we print the number of wheels for BMW, let's run this code. You can see that we get 10 here. Okay, this is because now we have assigned it a new value of 10. So we are using this instance method to modify this class attribute. Now, let's talk about instance attributes. So unlike class attributes that are defined inside of a class, but outside of a method, instance attributes are defined inside of a method. And instance attributes are specific to each instance. Okay, they are specific to each instance. So for example here, if we check, let's check the color of BMW. The color here. What do we get? So we get black. Okay, because this is the color that we have assigned this BMW when we created this BMW object. And if we check for Honda, the color of Honda, you can see that we get white. Okay, so instance attributes are specific to each instance. We can also modify instance attributes inside of an instance method. So for example, let's say we want to change the color of BMW from black to red. So what we have to do here is access the color variable. So we use self.color and then assign it a new value. Let's say red. Now, for BMW to use this color, we need to call this method here on the BMW. So if we call this method on the BMW, we say BMW.startCar method. Okay, we are calling the startCar method because we are using the startCar method to modify the color attribute. So now, when we check the color of BMW here, you can see that we get red. The color has changed from the initial color of black to red. So we have been able to modify this instance attribute using this instance method. So this instance method has access to both class attributes and instance attributes. And it can modify both class attributes and instance attributes. Class attributes do not belong to a specific object. They are defined outside of this init method, and they are shared by all the objects that belong to the class. On the other hand, instance attributes are specific to each instance or each object. And both of these attributes, class attributes and instance attributes, can be modified inside of this instance method. That's what you have to know about class attributes and instance attributes. So we already looked at this instance method here. So the first parameter of this instance method is the self keyword. This is because this instance method that we have here is bound to the object. Okay, the self parameter here is a placeholder for an object. So when we create an object here, like we create a BMW object here, this BMW is passed as an argument to this self parameter. So this makes it possible for this BMW to be able to access this method. That's why to access this method, we use the dot notation. We say BMW.startCar method. Okay? Now, we have also seen that the instance method has access to both class attributes and instance attributes. And it can modify both class attributes and instance attributes. Now, instance methods are not the only type of methods that we can create for our classes. There's another type of method that we're going to look at. First, let's remove this part here. So the other type of method that we can create for our classes is called class method. And one way that we can use to create this method is to use a decorator. So this decorator is known as class method decorator. So under this decorator, we define our class method. So let's say we want to create a class method that will check the type of car that we have created here. Okay, if this type of car, let's say, is a truck, we want this method to double the number of wheels. So this method will access this class attribute and double the number of wheels if the type of car that we have created is a truck. So let's create a method called check car. Okay, and notice that the first parameter here is CLS. This is because this class method is bound to the class itself. It's not like this instance method that has self as its first parameter. This instance method is bound to the object. But the class method is bound to the class itself. That's why the first parameter is CLS. Now, let's pass a parameter here. So this parameter, let's just call this truck. Okay? And we'll pass it a default value of, let's say, false. So what we want is, we want to be able to check the car type, okay, that we are going to create. And if this car type is a truck, we want to double the number of wheels. So we are going to use a conditional statement here. So we'll say, if this car type is a truck, we want the number of wheels to be doubled. So first, we are going to access the number of wheels, okay, and then double this number of wheels by multiplying the number of wheels by 2. And we want this method to return, let's use an F string here, number of wheels of truck is, and then we'll say CLS dot number of wheels. So if the car type is truck, then we are going to double the number of wheels. However, if this car is not a truck, we want this method to return number of wheels of car is this CLS dot number of wheels. This means that we are going to maintain the same number of wheels, which is 4 here. Now, we can call this class method on the instances of this class. So for example, let's remove this part here. Let's say we want to check the type of car that this BMW is. So we'll say BMW dot check car. We use a check car method here. Okay? And then for truck, we are going to say true. Okay? This car, this BMW object that we've created is of type truck. It's a truck. Okay? So now, when we print this method here, and we run this code, what we get, so we get number of wheels is 8. So because the car type is truck, this method has accessed this class attribute and modified the attribute by multiplying this attribute by 2, making the number of wheels 8. Okay? Now, if we say, no, this is not a truck, this is just a normal car, so we pass it a Boolean value of false here. Okay? Or if we don't want to, we can just leave it like that. All right? Because we have already passed it a default value of false here. So if we don't pass any argument here, this method will use this default value of false that we've passed here. So if we run this code, you can see that we get number of wheels is 4. So what can we conclude from using this class method here? So this class method that we've created here has access to the class attribute. Okay? It can access a class attribute and it can modify this class attribute. We've used it here to change this class attribute from 4 to 8. Okay? And we can also access this class attribute using the instances of the class. So if you want to modify a class attribute, you can either use this instance method. We've seen that instance methods have access to class attributes and instance attributes. Or you can use the class method. The class method has access to class attributes. However, this class method does not have access to the instance attributes. Okay, so if you want to modify these instance attributes, then you have to use the instance method. But if you want to modify the class attribute, you can use the class method. So the first parameter is CLS. This is because this class method is bound to the class itself. It's not bound to the object. But for the instance method, the first parameter is self because this method is bound to the objects. So that's the difference between instance methods and class methods. Welcome back. Now, we have looked at two types of methods. So far, we have looked at the instance method and the class method here. Let's comment this part out and let's add class method here. So we have looked at instance methods and class methods. So instance methods, the first parameter is self because these methods are bound to the object. And then the class method, the first parameter is CLS because this method here, this class method is bound to the class itself. Now, instance methods are usually used when you want to interact with the instance attributes. We've seen how instance methods can modify instance attributes. Class method, obviously they're used when you want to interact with class attributes. We've seen how this class method has been used to modify this class attribute. Now, there is another type of method that we can have or that we can add to our classes. So this method is usually used when you want to create a method to your class that doesn't need any interaction with any of the attributes in the class. This method doesn't need interaction with the class attributes or the instance attributes. This type of method is known as a utility method. So it's basically for doing things within the class that do not need access to either class attributes or instance attributes. The name of the method is called static method. And to create this method, we use a decorator called static method, like that. So under this method, under this decorator, we define our method. Okay, so let's say we want to create a function here that will check the age of the car. So if the age of the car is, let's say, older than 3 years old, we want this method to return the car is old. Or if the age of the car is less than 3 years old, we want this method to return the car is relatively new. So we are going to define a method here. Let's call this method check age. Okay, and we're going to pass it one parameter, which is the age. So what we want is if age of this car is more than 3 years old, we want this method to return this car is old. If this car is less than 3 years old, we want this method to return this car is relatively new. So this is a static method. And you're seeing here that we are not interacting with any of these attributes in this method. Okay? And if you check here, this static method doesn't have any of these special parameters like self. This method here looks just like any other function, any other normal function that you're going to define in Python. So this is what static methods are used for. They're used for utility operations. When you want to do something within a class that doesn't require access to class attributes or instance attributes. So we're using this method here to check the age of the car. So if we call this method, let's call this method on a Honda. Okay, so we're going to say Honda dot check age, and then we'll pass it. Let's say this Honda that we have added here, this Honda car, is 5 years old. Now, when we print this, let's see what this check age method returns. If you run this code, you can see that this method returns this car is old. This is because this car is 5 years old. Let's comment out this part here. If, let's say, we check the age of the BMW dot check age, and let's say this BMW is 2 years old. Okay, if we run this code, what we get this car is relatively new. So this is another type of method that you can add to your classes, a static method. So we have looked at 3 types of methods that you can add to your classes. We have looked at instance methods, class methods, and static methods. So for instance and class methods, you actually use them if you want to interact with the class attributes or the instance attributes. For static methods, you use this method if you want to add some operation to your class that doesn't require interaction with either class attributes or instance attributes. Now let's start talking about the 4 pillars of object-oriented programming. Okay, so one of the 4 pillars of object-oriented programming is inheritance. We're going to start with inheritance. So what is inheritance? So inheritance is basically when you have 2 types of classes. You have the base class, and then you have the subclass. So the subclass inherits the methods and attributes of the base class. So the base class is also known as the parent class, and the subclass is also known as the child class. So let's create 2 classes here to demonstrate how inheritance works in Python classes. So I'm going to create a class here. I'll call this class main car. And then let's add some attributes to this class. So we'll add, let's say this class has make, model, and yeah. So let's say self dot make is equal to make dot model, and then self dot year. This is year of make is equal to year. So this is the base class or the parent class. Okay, now let's create another class here. This class will be the child class. So we'll say class, let's call this class electric car, and we are going to pass the main car here as an argument to this electric car, like that. So when we pass it as an argument, it means that this class here, this electric car class, is now inheriting methods and attributes of the main car. So this class now is the child class, and this main car class here is the parent class. So now this child class will have make, model, and then we have year. Okay, so we are going to add, let's add an extra attribute here. Let's say this is an electric car, so we add, let's say, battery status. Now what we want is, we want this child class to use the attributes of the parent class. As you can see here, the make attribute, the model attribute, and the year attribute are the same attributes that we have in the parent class. So to use these attributes that are in the parent class, we use the super function, the init method, and then pass it the make attribute, the model attribute, and the year attribute. So these attributes that we've passed here are the same attributes that we have in the parent class. And then we're going to create an attribute here for the battery that we've just added here, battery status, like that, which will be simply battery status. Now let's come back here. Let's add another attribute here. Let's say we want to have an attribute that will check the status of the engine. Okay, we want this attribute to check whether the engine is running or the engine is off. So we create a variable here called is engine running, and we'll give it a default value of false. Okay, now let's create a method here. Okay, we'll create a method, an instance method called display info, and what we want is we want this method here to display the information about the car. So what we're going to do is we're going to use an F string. So we'll say return, we want to return self dot make, then self dot model, and self, let's not forget the braces, self dot, yeah, just like that. Okay, so this instance method that we've created here belongs to the parent class. So now when we create an object that belongs to the child class, let's create an object here. Let's create an object. We're going to call this object, let's just call this object electric car, and this is an object of the child class. So we use the electric car class, and then the make of this car, let's say Tesla. It's an electric car, Tesla. And then we have model, let's say it's Model S. And then year of make, let's say it's 2014. And battery status, let's say it's good, or positive value of good. That's the battery status. So now we have created an instance of the child class. This instance of the child class can use the method and the attributes of the main class. Now, let's come back to this child class here and try to analyze what is happening. So in this child class, we are using this function here called super. So what does this function do? So when we create an object here that belongs to the electric car class, what the super function does is that the super function invokes this init method in the main car class. Okay, it invokes this method, and then it uses this method to assign values for make, model, and year. Okay, using this super function here, we are able to access this init method, this constructor in the main car class, and then we are able to use it to assign these values here. So for example, we have Tesla here, we have Model S, and we have year here, 2014. All these values get assigned using this init method in the main car class, in the parent class. Okay, so this ensures that we don't repeat this code here in the child class. So the child class is basically using the init method of the parent class. So this helps in making our code even shorter, because without inheritance, it means that we have to repeat this code here in the child class, but we don't have to because of this super function here. The super function ensures that this electric car class, which is the child class, uses this init method of the main car class or the parent class. So now, if we want to check or want to display the information of this car, we can use this display info method, which is a method of the parent class. So we can say electric car dot display info, and when we print this, run this code, what we get Tesla Model S and 2014, which is information of this object here, which belongs to the child class. Now we can also use the parent class to create objects. Okay, so for example, let's say we create an object, let's call this object main car, like that, and then we'll call the parent class, which is the main car class, and then we'll pass it value for make. Let's say make is Toyota, and we say model, let's say Camry, and year of make, let's say 2012, like that. Okay, so if you want to display this information of the main car, we can use the display info method. So we can say we can say main car and then access display info method. If we run this code, you can see now that here we get information for the main car, and then bottom here we get information for the car in the child class. So this is how inheritance works. With inheritance, we have an object of the child class using the attributes and the methods of the parent class. So instead of recreating this display info method in the child class, we are basically using the display info method that is in a parent class. And this makes our code even shorter. So that's the beauty of inheritance. Welcome back. Now let's continue talking about inheritance in Python classes. So now let's add another method to this class. Okay, so we're going to add a method that will interact with this engine running attribute. What we want this method to do is that we want this method to check if the engine is running. So if the engine is running, we want it to display or to return a message like engine is running, you're ready to go. And if the engine is not running, we want it to return engine is not running, you cannot go. So we are going to create here a method, okay, an instance method. So let's call this method check engine status, like that. Okay, so what this method will do is that it will first check if engine is running. And if engine is running, we want this method to return engine is running, you are ready, or let's say you're good to go, like that. Now if the engine is not running, we want this to return sorry, engine is not running, you can't go. Just like that. So we have created this instance method. So this instance method belongs to the parent class, but we can also use it with this object that belongs to the child class. So let's try to use it here with this electric car object. So we're going to say electric car dot check engine status, and let's print out what this method returns. If we run this code, what we get, so we get sorry, engine is not running, you can't go. This is because the engine is not running. We have a default value here of false, a Boolean value of false. If we change this to true and we run this code, what we get engine is running, you are good to go. So this is the beauty of inheritance. Instead of creating this method inside of the child class and making our code even longer, we are able to use the method inside of the parent class. Now, we can also create method in this child class that will be able to interact with the method in the parent class. Let's say, for example, we want to create a method here that will honk the car, but we want it to honk the car only when the engine is running. So we are going to create a method here, an instance method. Let's just call this method honk, like that. So what we want is, we want this method to interact with this check engine status method of the parent class. So we are going to use this super function here. So we'll say if super dot check engine status. Okay, this will check if the engine is running. We want this method to honk the horn. So we want it to return honk, 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 like that. But if the engine is not running, we want it to return can't honk, engine not running. Okay, so now, since this method is going to use the return values of this check engine status, let's change this here to true, and then change this to a Boolean value of false. So now, let's call this honk method on the electric car object. So let's say electric car dot honk. Just like that. If we run this code, what we get honk honk. Why is that? This is because the engine status here is true. So this check engine status method that we are interacting with using this super function is returning a true value. So because it is returning a true value, it means that this engine is running. So this method here returns honk honk. If we turn off the engine here, we change this to false, and we run this code, what we get, you see we get can't honk, engine not running. So we are using this super function here to interact with the check engine status method of the parent class. So that's the beauty of inheritance. You have classes using other classes' attributes and method. So the super function that we have looked at can do two things here. One, we can use this super function here to interact with the attributes of the parent class. But we can also use it to interact with the methods of the parent class. We're using it here in the honk method to interact with the check engine status method of the parent class. Welcome back. Now, let's talk about another pillar of object-oriented programming. And this pillar is abstraction. So what is abstraction? So what abstraction is basically hiding unnecessary details of implementation. And abstraction is a very fundamental concept in Python programming. This is because we see abstraction in a lot of functions that we use in Python. So for example, we use the print function. We know what the print function does. The print function prints information to the console. That's what it does. But the implementation of the print function, the code behind this print function, is hidden from us. So we know that if we pass a string here, for example, hello, and we run the code, the print function will print hello to the console. But we don't actually know how this is implemented under the hood. That information is hidden from us. Another good example is the length function. We know what the length function does. If we pass it a string or we pass it as a list, it will return the length of that list or string. But the implementation of this length function is hidden from us. We know what it does, we use it, but the code behind this length function is hidden from us. That's what abstraction is. So abstraction is basically hiding unnecessary details of implementation. Now, we can also achieve abstraction in Python classes. Now, to achieve abstraction in Python classes, we need to import a module. So we're going to import the abstract base class module. So we'll say from ABC, which is abstract base class, we want to import the abstract base class and the abstract method. Now, we are going to define a class here. Let's say we want to create a class of animals. So we are going to create a class called animals. So this class animals is going to use the abstract base class to define an abstract class. So we're going to pass ABC here, ABC. Okay, so this means that this class animals is going to use the abstract base class to define an abstract class. Now, inside of this class, we are going to add a method. Now, let's say we want these objects that we are going to create from this animals class to make animal noises. So we are going to create a method here. Let's call this method make noise, like that. And then we are going to pass. Now, this abstract class that we have created here cannot be implemented. This is a parent class. So from this animals class, we are going to create child classes. So this animals class provides a blueprint of what kind of classes we are going to create from this animals class. So this class is basically saying that if you are going to create a class from this animals class, you need to have a make noise method in your class. So if we create a child class here, let's create a dog class. Okay, let's create a dog class like that. And this dog class is inheriting from the animals class. So this dog class that inherits from the animals class is required to have the make noise method in its class. So we are going to add a make noise method to this class, and we want this method to return dog noises. So we say bark, bark. Okay, if we create another class here, let's create a cat class, and this cat class is also inheriting from the animals class. It is a child of the animals class. So because it is inheriting from this abstract class, we need to add a make noise method to this class, like that. So we add def make noise, and we want this class to return noises that a cat makes. Let's say meow, meow, like that. So this animals class is the abstract class. So why is it an abstract class? Because this abstract class does not provide any details of implementation. All this animals class does is provide a blueprint, sort of like instructions, that if you are going to inherit from me, if you are going to create a class from this animals class, you need to have a make noise method in your class. Now, to make this method an abstract method, we need to add a decorator right on top. This decorator is the abstract method decorator. So this class that we've created here, this animals class, cannot be instantiated. We cannot create objects that belong to this animals class. If we try here, let's try. Let's create animal 1. Okay, try to create animal 1, and this animal belongs to the animals class. Okay, if we try to run this code, you see here that we get a type error. Can't instantiate abstract class animals with abstract method make noise. So we cannot instantiate objects of the animals class. So this abstract class does not provide any details of how this make noise method should be implemented. So the implementation of this make noise method is left to these subclasses, these classes that are inheriting from the animals class. It is left to the cat class and the dog class in our case here. So the implementation details are not provided in this animals class. That's why this animals class is an abstract class. So if we want to instantiate objects, we can only instantiate objects of this dog class and this cat class. So for example, we can say cat1, cat class. So we can use the make noise method on this cat class. So let's say cat1 dot make noise. Okay, and if we run this code, what did we miss? We need to get rid of this one here, like that. Now, run this code, we get meow meow. So this cat object is using this method here, the make noise object that is in the cat class. If we create an object that belongs to the dog, let's say dog1, dog, and we use this dog to call the make noise method. So we say dog1, make noise. And we print this out, run this code, you can see that it makes these dog noises. So this is what abstraction in Python is. Abstraction is simply creating an abstract class. Okay? This abstract class provides no details of the implementation. The implementation details are left to these subclasses, these classes that are inheriting from this abstract class. So if any of these classes doesn't have the make noise method, then this code will generate an error. So for example, let's change this make noise method. Let's change it to, let's say, mark noise method, and let's run this code. Okay, you can see now that we get an error here because this code is trying to use this make noise method that is in the abstract class. So the importance of using abstraction in Python classes is that when you have methods, let's say you want to create methods that you want all the subclasses to have, then you can use this abstraction class. If the method that you have added to this abstract class is not added, then the code will generate an error. So using abstraction is a good way of checking that the implementation of the code is complete. Okay, once a method has been added to the abstract class, it means that any class that is inheriting from that class must implement that method. How the method is implemented depends on the class itself. So those details are not provided in the abstract class. It doesn't provide those details. So this is how abstraction works in Python classes. Welcome back. Now let's talk about operator overloading in Python. What is operator overloading? So we are looking at two words here. There's operator and there is overloading. So let me give you an example to help you understand operator overloading. So let's say you have one tool in your house, and that tool is a knife. Then it means that you are going to use that tool for different tasks. You use it to cut bread, you're going to use it to cut meat, you're going to use the same knife to screw something, unscrew something. You can use that knife to open a can of beans. You use the same knife to put butter on your bread. You may use the hand of a knife to break something. So we can say that this tool is overloaded because you are using this tool for various tasks. It's one tool, but you can customize it to use it for various tasks. That's what operator overloading is. You have one operator, and this one operator can be customized to work with different data types. That's what operator overloading is. Now, to help us understand what operator overloading is, we are going to use this operator, the addition operator. So the addition operator is used for various tasks in Python. So for example, if we have two numbers, so we have my number 2 and we have another number, the value of 3, and we wanted to perform an arithmetic operation on these two numbers. We wanted to add these two numbers. We can use this addition operator. Okay, my number plus another number, and we get, you can see here that we get 5, right? If we had, let's say, two lists, and we wanted to merge these two lists, we have my list. Let's say we have in this list 1 and 2, and then we have another list. And in this list we have, let's say, 3 and 4, and we wanted to 3 and 4 here, and we want to merge these two lists. We can use the same addition operator. If we say print my list plus another list, run this code, you can see that we get a merged list right here. If we have two strings, my string, and in the string says hello, like that, and then we have another string here, and this another string says world, and we wanted to concatenate, to join these two strings, we can use the same addition operator. With my string plus another string, and we get what? We get one string here. So you see, you have one operator, but this operator is used for different tasks. Okay, so how is it possible that we can use this addition operator for various tasks? Well, this is possible because of one special method. Special methods in Python are basically these methods that have double underscores. You have opening double underscore and closing double underscore. And one of these methods is the add method. So this is the method that makes it possible for us to be able to carry out all these operations with the addition operator. So what does this method do? First, remember, when you create an object, when you create an object in Python, that object is added to a class. So if we check here, my number, the class where my number belongs to, using the type function, you can see that my number belongs to the int class. So the int class provides methods that we can use to perform operations on int objects. And if we check these methods using the dir function, let's check the methods of the int class. Okay, run this code. If we go up here, one of the methods is the add method. This is the method that gets called whenever we try to perform arithmetic operations using numbers in Python. So when we use this addition operator on these two numbers to perform an arithmetic operation, Python calls this add method. Basically, what happens behind the scene is that my number here calls this method, this add method, and this other number is passed as an argument to the add method. This is what happens every time we use the addition operator. So if we run this code, you can see that we get 5 here and we get 5 here. So this is what happens behind the scenes. The add method gets called, and this add method is used to perform this operation. So we can say that the add method overloads the addition operator for the int class, meaning that it customizes the behavior of this addition operator for the int class. That's what makes it possible for us to be able to add these two numbers. Without the add method, the Python interpreter wouldn't know what to do with this addition operator when working with int data types. So this method here, the add method, the double underscore add double underscore, customizes the behavior. It overloads the behavior of the addition operator so that it's able to work with int data types. That's what makes it possible for us to be able to add these two numbers. So whenever we use this operator, the addition operator on int numbers, this add method performs the arithmetic operation. It adds these two numbers and we get the sum of these two numbers. If we move on, let's check, let's look at lists. Okay, we are going to create a list here, my list. And this list has 1 and 2. And then we have another list here with 3 and 4, the same list. Now, if we check the type of my list, for example, the type of my list here, let's comment out this part. If we check here, you can see that my list belongs to the list class. Now, let's check the methods of the list class. Okay, we'll use the dir function to check the method of the list class. And you can see that one of the methods here is the add method. So this add method overloads the addition operator. It customizes the behavior of the addition operator. It's because of this method right here, the add method, that we are able to merge two lists. So the behavior has been implemented by this add method. Without this add method, in this list class, we wouldn't be able to merge these two lists. So this method overloads that. So whenever we have two lists and we want to merge them, basically what happens behind the scene is that my list here calls this add method, and this another list is passed as an argument to this method. Like that. Okay? And these two lists, what happens? They get merged. So the behavior is customized by the add method in the list class. So the add method overloads this addition operator for the list class. It makes it possible for objects of the list class to be able to use this operator. It's the same thing if we check strings. Okay, we have a string here, hello, and we check which class this string belongs to, and my string. So this string belongs to the string class. And if we check the methods of the string class, what do we get here? One of the methods that we get is the add method. So this is the method that gets called every time we try to concatenate two strings. So this add method here overloads the addition operator for the string class. It makes it possible for this class to be able to concatenate strings. So if we have two strings here, another string, and we have word here, and we use this addition operator to concatenate these two strings, this is what happens. My string calls the add method, and this another string is passed as an argument. That's what happens behind the scenes. And if we run this code, what did we miss? Okay, here we need to just do this here. We run this code again. What did we miss again? Okay, we need to add another string here, not another list, like that. Okay, now when we run this code here, you can see that we get hello world. So that's what happens. So the add method, the double underscore add double underscore, overloads this addition operator for the string class. That's what makes it possible for us to be able to use it on string objects. So without this method in the class, the interpreter, the Python interpreter, wouldn't know what to do with this operator. So that's what operator overloading is. You have one operator that can be customized to work with different data types. Now, in the next video, let's look at how we can achieve operator overloading in user-defined classes. Welcome back. Now, let's talk about how we can achieve operator overloading in user-defined classes. So I'm going to define a simple class here. I'll call this class some number. Okay, and let's say we take one argument. Okay, pass it a number here, and let's bind this number to the object. So say self number is equal to number, just like that. Now let's create two objects of this class. Okay, so the first object is num1, and we'll call some number and pass it one argument, let's say 3 here, and let's create another object which will be num2 and call some number, pass it another argument, let's say 2, just like that. Now let's try to perform an arithmetic operation using these two numbers. Let's try to sum these two numbers. So we'll save that to a variable called results, and it will be num1 plus num2. Now what happens if we try to print these results here? So you can see that we're getting a type error. Okay, it's not working. So basically the error is that this addition operator that we're using here is not supported for these objects that we have created for this class. So why is that? Well, remember in the previous video, when we were using the addition operator with the int class, the list class, and the string class, all these classes had one thing in common. They all had this special method, the add method. Okay, this class that we've created here doesn't have that add method. So basically, without that method, the Python interpreter doesn't know what to do with this addition operator when working with these objects that we've created here. We need to tell this interpreter what to do with this addition operator when working with the objects of this class. Okay, if we check here, okay, let's check the methods that are available to this class that we've created here. Okay, we'll use the dir function and pass it some number. Run this code. These are the methods that are available to this class that we've created here. And you can see that we don't have the add method. We don't have the double underscore add double underscore special method. So because of that, this operation cannot work. So what do we need to do to make this work? Well, we need to add the method. Okay, so when we add the method will overload this addition operator for this class, meaning that it will customize the behavior of the addition operator for this class so that we are able to work with this operator when dealing with objects of this class. So overloading this class with the additional operator will make it possible for us to carry out this arithmetic operation. So to overload this class, with the addition operator, we need to add the add method. Okay, so let's add it here. We add this method, and then in this method, we'll pass instructions on what we need to happen. So we want to return the results of num1 here plus other dot, let's say, number. So now let's try to run this code again. Let's uncomment this part of the code. If we run this, what happens? Well, we're getting an error. This should be number here, like that. Okay, let's run it again. You can see now that the operation is working. We get 5. Okay, so this method here has customized the behavior of the addition operator for this class. Okay, this method has overloaded the addition operator for this class. Now, when we use this addition operator, this object here, the num1 object, okay, the num1 object calls the add method, and the num2 object here is passed as an argument to this method, just like that. And when we run this code, you can see that we get 5 here. So without this method, the operation of adding, okay, this operation of adding num1 here to num2 like this will not work. So this method that we've added here customizes the behavior of the addition operator. As a matter of fact, if we want, we can even change this to minus, just like that. And if we run this code, you can see now that we get 1, because this addition operator is following the instructions that have been set in this method right here. That's how you can achieve operator overloading in user-defined classes. Let's look at another example. Okay, let's say we want to in this example, we are adding these 2 numbers. Let's say we want to subtract. Okay, so we want to, let's say we print num2 minus num1. Let's comment out this part here, the first part. Right. If we run this code, you can see now that we also get another error here. Okay, why? Because this subtraction operator that we're using here is not supported. So how can we make this work? We need to overload this class here with the sub operator. So how can we do that? So there is another method that supports this subtraction operator. It is the double underscore sub double underscore. Okay, so now we want this to return minus other dot number, just like that. When we run this code, you can see now that we get -1. Now it's working. So the sub method here, okay, has overloaded this subtraction operator for this class. Now, when we use this subtraction operator on objects of this class, this method gets called, and the instructions that have been set in this method here are used to carry out this operation. If we want, we can actually change this and say add. Okay, when we run this code, you can see now that we get 5 with this sub method. So the sub method has customized the behavior of this subtraction operator. So this is how you can achieve operator overloading in user-defined classes. See you in the next video. Welcome back. Now I have a challenge for you. Okay, so I want you to continue working on this class here. But what I want you to do now is, remember we've done we've performed 2 operations on this class. We've done the adding here, we've used the addition operator, and we've also used the subtraction operator. Now what I want you to do is, I want you to be able to multiply these objects that we have here. For example, num1 here by num2. And I want you also to be able to check if num1 is num2. So this class should be able to perform these two operations here. Multiply num1 by num2, or check if num1 is num2. So I want you to use operator overloading to solve this challenge. So modify this class with some operator overloading and make it possible for us to carry out these two operations here. See you in the next video. Welcome back. Now let's solve this challenge together. So the challenge was to overload this class here with the multiplication operator and the is operator. So let's start with the multiplication operator. So to overload this class with the multiplication operator, there is a special method that we can use, and this method is the _mul__ method. This is the method that we can use to overload the multiplication operator. So we are going to say return number times other dot number, just like that. Okay, if we run this code, you can see that we get 6 here. So this method here has overloaded the multiplication operator for this class here. Okay, now when it comes to the is operator here, there is no direct method that we can use to overload the is operator. The is operator is an identity operator. It compares if two objects are identical or if they share the same memory location. So this operator is not meant to be customized. So there's no direct method that we can use to overload this operator. Okay, so what you have to know is that not all operators can be overloaded. There are certain operators that can be overloaded and there are certain operators that cannot be overloaded. And the is operator is one of those operators that we cannot overload because this is an identity operator. Okay, if we were comparing if these two items are equal, okay, if this was an equality test, for example, if we were using the equality operator like this, then we can overload this class with the equality method, okay, which is the _eq method. Okay, so this method here is used to overload the equality operator. Okay, but for the is operator, we don't have a method that we can use to overload the is operator. So this shows that it's not all operators that can be overloaded. So now, when you're overloading, it's important to be consistent. So let's now change this back to addition because we are adding these two numbers. So we're using the add method to overload the add operator. So we're changing this to addition, and then we're going to change this back to minus, just like that. So now we have overloaded the addition operator, the subtraction operator, and the multiplication operator. Okay, so with multiplication operator, we are multiplying these two numbers. With the subtraction operator, we are subtracting these numbers, and with the addition operator, we are adding these two numbers or these two objects. Now, let's talk about polymorphism in Python. So polymorphism is one of the pillars of object-oriented programming. So what is polymorphism? So polymorphism simply means many forms. Okay, so you have an object, or let's say you have a function, a method, or an operator that has the same name, but it can take many forms, meaning that it can be used on different objects. That's what polymorphism is. So a good example of a function that demonstrates polymorphism is the length function. So remember, you can use the length function to find the length of a string. But we can also use the same length function to find the length, let's say, of a dictionary. Okay? If you use it on a dictionary, for example, it will return the number of keys in that dictionary. You can also use it to find the length, let's say, of a tuple. Okay? So this is just one function. If we print all this out here, length of a string here, let's run this code. So you can see that it's working with different objects. So this is a form of polymorphism. You have this one function, but it's able to work with different objects. Now, we can also achieve polymorphism in user-defined classes. So let's define a class here. This class will help us demonstrate two pillars of object-oriented programming: polymorphism and inheritance. So I'm going to define a class here called car. Okay, and inside this class, I'll add a method. Let's call this method start car. And this method will return I start gasoline and electric cars. Now let's create child classes that will inherit from this car class. So the first class that we're going to create is the Tesla class. Okay, so this Tesla class is inheriting from this car class. Now, let's pass for now. Let's create another class here. Let's call this class the Honda class. And this class is also inheriting from the car class. Like that. And let's also pass here for now. Now, these two classes that we've created here, the Tesla class and the Honda class, are inheriting from the parent class, which is the car class. So they have access to the method that belongs to the parent class. So if we create objects of these child classes here, let's say, for example, create an object of the Tesla class, object 1 here. This object is of the Tesla class. This object will have access to the method of the car class. So we can actually call car1 here setCar method. If we run this here, so we get I start gasoline and electric cars. This is the same with the Honda class here. The object of the Honda class will have access to this method. Now, the method in the car class here returns I start gasoline and electric cars. So this method here does not actually represent the characteristics of the Tesla car, because, well, this Tesla car is an electric car, so it doesn't start with gasoline. So the Tesla car here, or the Tesla class, may want to modify this start car method here so that it meets the characteristics of a Tesla car. Okay? This is the same with the Honda class here. So the Honda works with gasoline. It doesn't work with electricity. So this method as well does not represent the characteristics of this Honda car. So these two classes may want to re-implement these methods here to suit their needs. So we are going to re-implement the same method that they are inheriting from the parent class. We're going to do that for both of these classes. So here we'll define another startCar method. But this time we want this method to return I start electric cars. This is for the Tesla, because the Tesla is an electric car. And for the Honda here, we'll use the same startCar method. And this time, we'll re-implement this method to return I start gasoline cars. So what we have now is these two child classes that are inheriting from the car class. They are re-implementing the method that they have inherited from the parent class. So this is what polymorphism is. Now, the process of re-implementing the same method that has been defined in the parent class in the child classes is called method overriding. So this method that we have defined here in the Tesla class is now overriding the method that is in the parent class. So when we define an object of the Tesla class and then we call the start car method, the start car method that is in the Tesla class will now run. So when we run this code here now, you can see that we get I start electric cars. So the start car method that is in the Tesla car is now running. If we do the same for the Honda here, let's create another object here called object 2. Okay, on a Honda class. If we call the start car method on object 2 here, that we have on car 2 here, which is an object of the Honda class. If we run this code, we get I start gasoline cars. So the start car method that is in the Honda car is running. So this method here is overriding the start car method that is in the parent class. So this is how polymorphism works in user-defined classes. So what we have here is we have a method, the same method being used in different classes. The start car method here is being used by objects of the Tesla class, and the start car method here is being used by objects of the Honda class. So what is the benefit of polymorphism in user-defined classes? Well, the benefit is that polymorphism allows code reusability, okay, by allowing you to define a common interface for different types of objects. In our case here, the common interface is that these objects here, they share the same method. Okay, so for example, if we want to create a function, for example, that calls the method of these classes, all we have to do is to create one function, and this function will call the methods of all these classes because these classes share a common interface. So using polymorphism makes it possible for us to reuse our code. So for example, let's say we want to create a function that will call this start car method. Okay, we only have to define one function. So let's call this function run car, and it takes one argument, which is a car, and we want this function to return car and call start car method. Now, when we call this function, okay, let's call this function here run car function, and let's define the objects of these two classes. We'll define car1, which will be the object of the Tesla class, and we define car2, which will be the object of the Honda class. And let's define the main car here. Let's call this the main car, which will be the object of the parent class, the car class. So we have these objects here, and we have created a function here, this function that we'll call the start car method. Now, when we call this function, let's pass it main car. Okay, the main car as the argument. If we run this code here, what we get, so we get I start gasoline and electric cars, which is the start car method in the parent class, because we are calling this method right now on the object of the parent class. If we change this to car1, okay, this is car1 now, which is the object of the Tesla class. If we run this code, we get I start electric cars. If we if we change this to car2 here, okay, and run this code, why did we get an error? Okay, we didn't call car2 here. Now let's run it again. So we get I start gasoline cars. So this is the benefit of using polymorphism. defining same methods for different classes. We are now able to use the same function on all these classes because they share the same interface. If it wasn't for the same interface, it means that we have to create 3 different functions for all these classes. So that's one of the benefits of polymorphism. See you in the next video. Welcome back. Now let's talk about encapsulation. So encapsulation is the 4th pillar of object-oriented programming. So what is encapsulation? So encapsulation is basically putting data in a unit. That's what it means. Putting data in a unit. So you have attributes and methods, and you put this data in a unit. So for example, a class is a unit. So you put it in a unit, and then you protect this data from unauthorized access. So that ensures that the data is used in a consistent and controlled manner. So how do we achieve encapsulation in Python? So let's define a class here. Okay, let's define a class. Let's call this class student. And let's say we have one attribute. Let's define an attribute. Okay, so let's say we have age here. Age of a student, which is 23. So Python uses what we call access modifiers to achieve encapsulation. So in Python, data can either be public, private, or protected. Now, by default, when you define an attribute, like we've defined an attribute here, okay, this attribute is a public attribute. So this means that we can access this attribute within this class and outside of this class. So for example, if we create an object of this class, let's call this object 1. Okay, and this is an object of the student class. This object can access this age attribute outside of this class here. Okay, if we run this code here, so we get 23. So we can access this attribute inside of this class here and also outside of this class, because this is a public attribute. So a public attribute is meant to be accessed from within the class and outside of the class. Now, a second level of protection that you can give to attributes and methods in a class, or to data in a class, is protected. Okay, you can make them protected. So how do you make attributes protected? So to make an attribute protected, you add a single underscore. So you prefix the name with a single underscore. So let's add another attribute here. Let's say name. Let's say the name is Peter. So this attribute here that we have prefixed with a single underscore is known as a protected attribute. Now, a protected attribute can also be accessed outside of this class here. Okay, if we try to access it outside of this class here, we access Peter. I mean the name Peter. If we run this code here, you can see that we get Peter. We can also access it inside of the class. Let's create an instance method here. Let's call this show attributes. Okay, and let's say we want this to return self name, like that. So we can access this attribute, the protected attribute, outside of this class. We can also access it here using this instance method. So for example, we can say student show attributes, like that. Run this code, you can see that we get another Peter here. So public attributes, okay, and protected attributes can be accessed from within the class and outside the class. So why is this attribute protected when it can just be accessed from anywhere, just like the public attribute? Well, when you add a single underscore to an attribute, you don't actually change how that attribute is accessed. It it doesn't provide any actual protection to that attribute. So adding a single underscore to an attribute is basically a way of telling people that use the code that this attribute that you have defined here is meant to be protected. So they shouldn't use it outside of this unit. This attribute is meant to be used only inside of this unit or its subclasses. That's what it means when an attribute is protected. Okay? Now, a third level of protection that you can add to the attribute is to prefix with double underscore, like that. Okay, so let's add another attribute here. Let's say, for example, gender. Okay, and let's say it has a value of male. Okay, so when you prefix an attribute with a double underscore here, you are making this attribute private attribute. So a private attribute is only meant to be accessed inside of this class. Okay, inside of this class and inside of this class's methods. That's the only way we can access a private attribute. So for example, if we try here to access this gender attribute we have prefixed with the with double underscore, if we try here, okay, try to access it outside of this class using this object, if we run this code here, we get an attribute error. Okay, student one object has no attribute gender. Okay, this class has an attribute called gender, but since we are trying to access it outside of the class, we cannot because it is a private attribute. So we can only access private attributes within the class. If we add it here, let's add it to this instance method here, okay, gender, and then we try to access it using this instance method, okay, from outside. So we use the show, we call the show attributes method, and let's comment out this part here. Okay, run this code here. You can see now that we get male. So a private attribute is only meant to be accessed within this class and within these methods. So by default, when you define an attribute and then that attribute is not prefixed with anything, that attribute is a public attribute, and then it can be accessed from anywhere within the program. Okay, the second level of protection is protected attribute. So with protected attribute, you add a single underscore, you prefix it with a single underscore. So a protected attribute can be accessed from anywhere within the program. It can be accessed and modified, but we protect it, or we add a single underscore as a way of telling other developers that this attribute right here is protected, meaning that they shouldn't use it outside of the class. This attribute is meant to be used only within the class and its subclasses. Third level of protection is when you add double underscore, you prefix the attribute with double underscore, and this makes this attribute private. Private means that this attribute can only be accessed inside of the class and its methods, but it cannot be accessed outside of the class. If we try to access it here, we'll get an attribute error. See you in the next video. Welcome back. Now, the whole purpose of encapsulation obviously is to ensure that data is protected. So we put data in a unit and then we ensure that there is no unauthorized access to that data. That's the whole purpose of encapsulation. Now, even when data is protected, we still want to be able to access this data. So for example, let's look at this private attribute. So this gender here that we have added double underscore to is a private attribute. So we cannot access this attribute outside of this unit here. We can only access it using this show attributes method. So for example, if you want to see the value of this gender attribute, then we have to say student dot show attributes. If we run this code here, you can see that we get male. Now, if this attribute was not a private attribute, okay, if we remove this double underscore, Okay, the way we could access it would be to call this gender attribute directly. So we can say gender like that. Okay, if we run this code here, now we get male. Okay, so this is a much better way of accessing this attribute than using this show attributes method. Okay, when this is protected, we have to use this show attributes method, but this is not Pythonic. Okay, because when you see show attributes method, you don't know what it is that we are trying to access here. But if you see gender here, you know that we are trying to access the gender of this student one here. So this is more Pythonic. So Python provides a way that we can keep our attributes private, but still be able to access them as if they are not private attributes. And we're going to look at that in a moment. Now, another issue with this code is that we can modify this private attribute. Okay, we can modify this attribute using this show attributes method. So for example, here we can say self.gender, and then we can assign it a value of, say, let's say female, like that. Okay, if we print here, if we call show attributes method, if we run this code, you can see that the value has changed to female. Now, the problem is that there is no way of controlling the values that are assigned to this gender attribute. So somebody can assign a 2 here, like that. Okay, if we run this code, our gender has changed to 2. So there is no way of controlling the data that is assigned to this gender attribute. So Python has a way of ensuring that we control the data that is assigned to this private attribute. So Python has a decorator called property decorator. Okay, so using this property decorator, we can do 2 things. First, we can access this gender attribute, this private attribute, as if it wasn't a private attribute. So we can use this property decorator to create 2 types of methods in our class: a getter method and a setter method. So we use the getter method to access this private attribute, and then we use the setter method to modify this private attribute. So let's modify this method here. Okay, let's make this into a getter method using this property decorator. So we are going to add at property on top of this method, like that. And then we'll change this name to gender, like that. So once we do this, then we can access this gender attribute here, okay, as if it was a public attribute. So now, if we want to access this gender value here, we can just say gender, or we can say student1 and then call gender, like that. Okay, this is the same way we would access it if it was a public attribute. If we run this code now, you can see that we get male. So this is a getter method. Okay, this creates a getter method. So this method here is used to retrieve the value of this gender attribute that we have here, this private attribute. Now, once we create a getter method, we can create a setter method. We'll use the setter method to modify this gender attribute in a controlled manner. Okay, we want to make sure that the values that are assigned to this gender attribute are only valid values. So we'll create another method here, and we'll call this method gender, like that. Okay, and right on top here, we'll add another decorator. Okay, gender dot setter, like that. Okay, so using this property decorator, we have created a getter method here, and now a setter method. So this is the method that we use to assign values to this gender attribute, this private attribute. So this is a setter method. Okay, This is a setup method. So we use the setup method to assign values to this gender attribute in a controlled manner. Okay, so for example, let's say we want only 3 values to be assigned to this gender attribute. So we can create a list here. Let's create a list of values called, let's just call this gender values. Gender values, and then we'll create a list here. So we only want 3 values to be assigned to this gender attribute. So we want male, and then we want female, and let's say we want other, like that. So if somebody wants to change the value of this gender attribute, they will only have to either put female or other. Okay, if it's not male, then it can only be female or other. So now let's use a conditional statement here to check. Okay, and then we need to add a parameter here which will be value. So if value, okay, that is, if the value assigned, if the value that a person wants to assign to this gender attribute, okay, is in this list of values. So we'll use the in operator. We'll say if it's in gender values, then it can be assigned to this gender attribute. Then we'll say self.gender will be the value, like that. Okay, so for this value to be assigned to this private attribute, it has to be one of the values in this list that we have here. Okay, if the value assigned, okay, if the value that a person is trying to assign to this gender attribute is not in this list, let's add an else block here. We want to ensure that the person gets a message. So, we want our code to print, please enter a valid gender, like that. Okay, so now if we want to assign a new value to our gender attribute here, we can say student1 dot gender and then assign it a value. Let's say the value is male, like that. So, we already have male here. Let's say the value is female. If we run this code, where did we go wrong here? Oh, we don't have to call our setter method here. Okay, let's run this code again. If we run this code, you can see that we have female as the new value of this gender attribute. If we want, we can change this to other. Okay, these are the 3 values that we allow: male, female, or other. If we run this, we get other as the new gender. If a person enters something that is not valid, let's say bi, like that, we run this code, you see, now we get a message here. Please enter a valid gender, and then we get the default value of male, meaning that this gender attribute has not been changed because the value that has been entered by a person is not valid. So this is how you can use this property decorator. Okay, so you create a getter method. This is the method that you use to view the value of a private attribute. And then this is the setter method. The setter method is used to assign values to this private attribute in a controlled manner. You want to make sure that the values that are assigned to this gender attribute are only the values that are allowed. So in our case here, we have 3 values. Okay, so this is a more Pythonic way of implementing encapsulation. See you in the next video. Welcome back. Now let's talk about method overloading in Python classes. So what is method overloading? So method overloading is a situation where you have a class, and then inside of this class you have more than one method, and these methods have the same name. Okay, so these methods have the same name, but they take different number of arguments or different types of arguments. So how it's supposed to work is that when you create an instance of that class and you call the method that matches the number of arguments or the type of arguments that you have passed should get invoked. That's how method overloading is supposed to work. Now let's see how we can achieve method overloading in Python classes. So we are going to create a class here called add numbers, And inside of this class, we'll create two methods that have the same name. So let's call the first method some numbers. Okay. And let's say it takes two arguments. So we have num1 here and num2. So we want this to return the sum of num1, num2, and yeah, num1 and num2, just like that. Now, let's create another method. Okay, this will have the same name. So it will be some numbers. And this one takes a different number of arguments. So let's say this one takes 3 arguments. So it takes num1, num2, and num3, and it returns the sum of num1, num2, and num3. Okay, so we've created a class here that has two methods, and these methods have the same name, but they take different number of arguments. The first one takes 2 here, num1 and num2. So when we call this, we're supposed to pass 2 arguments, num1 and num2. The second one takes 3 arguments. So how this is supposed to work is that when we create an instance of this class, and then we pass it some arguments, we call a method and pass it some arguments. If we pass it 2 arguments, this method here is supposed to run. Okay, if we pass it 3 arguments, this other method here is supposed to run. That's how it's supposed to work. So let's see if this works. So we are going to create an instance of this class. Let's call this results. Okay, and this is an instance of this add numbers class, like that. So now we are going to call these methods. So what we want is we want to invoke this first method here. So we are going to pass 2 arguments. So we'll say results is equal to results dot some numbers, like that. Okay, and now we'll pass it, let's say 12 and 36, because we are trying to invoke the first method here. So we pass the number of arguments that match the first one here. Now let's print this result. So when we run this code, what happens? So you can see here that we are getting a type error. Okay, add numbers is missing one required positional argument, num3. Okay, so now this type error is that we are missing an argument for this parameter here, num3. So what is happening here is that Python is only recognizing this method here. Okay, so the moment we define 2 methods with the same name, like we've done here, the latest definition here, okay, is overriding this previous definition. So now Python is not recognizing this other method. It's only recognizing this method. If we change this, okay, we make this the latest method. We add it below here, okay, like that. Now, when we run this code here, you can see that we get 48. It is now working. So because we've made this method that takes 2 arguments as the latest method, now this is the method that Python is recognizing. This other method is not being recognized. So if we pass another argument here, for example, to try to invoke this method that takes 3 arguments, let's say we add a 48 here, and we run this code here, you can see now that we get another type error. Okay, add numbers takes 3 positional arguments, but 4 were given. So now it's saying that we've given it more than it takes, because it's only recognizing this method here. Okay, if we take this method and we move it here, okay, and then we run this code, you can see now that it works. We get 96 because now Python is recognizing this latest method. So what does this tell us? This is telling us that method overloading doesn't work in Python. Python doesn't support method overloading. This is because if you have methods here with the same name, only one method will be recognized. Okay, so how can we get around this? So even though method overloading does not really work, there are ways that we can use to get around this problem, so that we have a class that takes different number of arguments. Okay, so what we can do here, for example, is, let's say, add only one method, okay, and then add a third parameter here, num3. Now, what we are going to do is we are going to add a default argument here of none. Okay, so now we are going to use a condition statement. So what this conditional statement will do, will check the number of arguments that have been passed. So if this num here, okay, if an argument for num3 is not passed, we want to sum only num1 and num2. So we'll say if num3 is none, okay, has a value of none, then we want this method to return the sum of num1 and num2. Else, if a value is passed for num3 as well, we want this to return the sum of num1, num2, and num3. Okay, that's the way we can work around this. So now we have passed 3 arguments here. Okay, let's see what happens when we run this code. You can see that we still get 96. Now, if we remove this other argument here, we remove 48. So now we've only passed 2 arguments. If we run this code here, you can see that we get 48. So now we've made our class a little bit flexible. So now it can take different number of arguments. So this is just one way you can get around not having method overloading in Python. So method overloading is not supported in Python. So you have to use other ways, like this way that we've used here, to get around it, to find a way to work with something that looks similar to method overloading. See you in the next video. Welcome back. Now that we've covered classes, it's time for a project. Let's do a small project. So what project are we going to do? Let's do a project about a shoe shop, a small business that sells shoes. So we've been asked to create a tracker for this business. So what we want is to create a tracker that will track their inventory and will track their sales. So if they bring in new shoes, for example, these shoes should be added to inventory. And when a shoe is sold, that shoe should be added to sales. Okay, so it should be removed from inventory and it should be added to sales. Okay, and then we should also be able to view the inventory, for example, to see how many shoes we have. We should also be able to view sales, for example, to see how many shoes we've sold and dollar amount of the shoes sold. So this is the simple tracker that we want to create. So that is the challenge. We're going to create this tracker together, and after we're done, you can also practice by creating your own tracker. That's how you learn. Okay, so we'll start by defining a class. So let's call this a shoe shop. Sounds like an appropriate name. Okay, we'll call this class shoe shop. Okay, now what we want is we want to have the name of the shop and the location of the shop. Okay, so let's add some parameters here, okay, which will be the name of the shop and the location of the shop. So this shoe tracker is supposed to track, let's say, inventory. Okay, so we are going to use a method to add shoes to the inventory. So let's call this method add shoe. So let's pass here for now. This will be used to add shoes to the inventory. So if we have a new order of shoes, these shoes should be added to the inventory. So we'll use this add shoe method. And we also want to be able to keep track of sales. So when a shoe is sold, we want to be able to add this shoe to sales. So let's say sell shoe, called sell shoe. And this will add the shoes that have been sold to sales. Okay, so let's add pass here as well. And what we also want, we want to be able to view how many shoes we have in the inventory. So let's create another method here called show inventory. Okay, so we'll use this method to view how many shoes we have. So this one will just return obviously self dot something like inventory, like that. We just use this method to see how many shoes we have. And we also want to be able to see how many shoes we've sold. Okay, so let's create another method here. Let's say sold shoes inventory. So this will keep track of all the shoes that we have sold, and we want this to obviously to return, let's say, sales, something like that. Okay, so this is basically what we are going to work with, and we'll keep modifying it until we get what we want. So let's define some attributes here. So we have self here, self.name. This will be the name of the shop, and then we have location. Okay, this is where the shop will be located. So this will be location. What we also want to have here is where we are going to keep these shoes, the inventory. So let's create a variable here called inventory. Okay, and this will be an empty dictionary. So it means that when shoes are brought into the shop, we are going to add these shoes to this inventory. So it will start off as an empty inventory. Let's also create another dictionary, and this time this will be sales. Okay, so if we make a cell, this cell will be added to this sales dictionary. So this is the structure of our tracker. So now let's come to the add shoe method. So what we want here is to add shoes to this inventory. So when shoes are brought in, we want to know the name of the shoe. So we need to take the name of the shoe and, okay, let's call this shoe name, And we also want to know how many shoes have been brought in. So these are the shoes that we're going to add to inventory. So the number of shoes, let's call this quantity. Okay, so this will be quantity, the number of shoes that have been brought into the shop. Now, the first thing that we want to do before we add a shoe to this dictionary, we first want to check if the shoe is already there. Okay, so first we want to check if shoe name, okay, this shoe that we've added here is in. If this shoe is already there, okay, if this shoe that has been brought in the shop is already there, then we want the quantity of this shoe to be added to the quantity that is already in the inventory. So we are going to access like that, okay, which is a dictionary, and the shoe name will be the key. The shoe name will be the key. And this key will have a value which will be the quantity that we already have plus the brought in quantity. So we're just going to add to the quantity that we already have. So for example, if we already have, let's say, 5 Jordans in our inventory, and then we bring in another 5 Jordans, then those 5 Jordans will be added to the 5 Jordans that we already have. So we are going to add quantity here, like that. Okay. Now, if we don't have it, okay, if we are starting off from empty, then it means that the shoe name, let's say we are starting off from 0, we are adding Jordans, and we don't have any Jordans in our inventory, then it means that the value of this key here, remember the key of this dictionary is the name of the shoe. So if we have 0 here, and then we bring in, let's say, 5 Jordans, then the value of this key will be basically the number of shoes that we have brought in, which will be the quantity. So if we are not starting from 0, then we are going to add the brought in quantity to the number that we already have. If we are starting from 0, then the quantity will be basically just the number that we are bringing in. So let's remove this pass here. Okay, so this is how we are going to add these shoes to our inventory. Okay, now, so when we add the shoes, we're going to add the shoe name and the quantity. Let's go to sales here. Okay, let's implement sales. How are we going to implement sales? So what we want is, we want to sell shoes that we have available in the inventory. Okay, that's how we want to sell shoe. We don't want to sell a shoe that's not available. So the first thing that we want to do here is to check. If somebody wants to make a sale of a shoe, we want to check if that shoe is available. So we want this method to be able to take the shoe name. Okay, it will also take a shoe name and the quantity. How many pairs of shoes that somebody wants to buy? Like that. So the first thing that we want to do is to check if shoe name is in inventory. If we do, then we're going to make a sale here. Okay, let's do pass here. And then if we don't have it, we want to say what? We say, let's return this shoe is out of stock. Okay, just like that. That's what we want to return if we don't have the shoe and somebody tries to make a purchase or somebody tries to process a purchase. They should get the shoe is out of stock. Okay, now if the shoe is in inventory, what else do we want to do before we authorize this sale? First, we need to check if we have enough quantity. Okay, so for example, if we have 2 pairs and the person wants to buy 5 pairs of that shoe, then it means that that transaction won't work. So first, we need to check that the quantity, okay, the quantity that is being requested for, the number of shoes that somebody wants to buy, is either less than or equal to what we have in the inventory. Okay, so we're going to access our inventory and then access the shoe name that somebody wants to buy, like that. So this key here will access the quantity of this shoe name. So for example, if somebody wants to buy Jordans, okay, these will be Jordans here, and this will access the quantity. Remember, the shoe name is a key and the quantity is the value of that key. So we are going to access the quantity here using the key, which is the shoe name. So what we want is, we want to check that the quantity that has been requested for what somebody wants to buy is either equal to what we have or less than what we have, because we can't sell what we don't have. So if somebody wants 5 pairs and we only have 3 pairs in our inventory, that transaction won't work. So we want to check that we have enough shoes to make that sale. So if we have enough shoes, what do we want to do? Okay, so if we have enough shoes, then the sale is going to happen. But when the sale happens, it means that we have to reduce the number of shoes that we have in the inventory because we have made a sale. So what we want is to go to our inventory here and access this shoe that has been sold, and then we want to reduce the quantity of this shoe. Okay, so when somebody makes a sale, we'll go to the inventory, access this shoe that we have in the inventory, and then reduce the number of shoes that we have in the inventory by the number of shoes that we have sold. Okay, now once we make this sale here, once we've reduced the number of shoes in the inventory because we've made a sale, we want these shoes to be added to sales. Okay, so just like we did here, the first thing that we need to do is check if this shoe is already in the sales dictionary. So if the shoe name, the shoe that we're trying to sell here, is already in sales, what we want is, we just want the quantity that has been sold to be added to the quantity that is already in sales. So if we already have sold 4 Jordans and we sell another 4 Jordans, we want the 4 Jordans to be added to the 4 Jordans that we already have. Okay, so we'll say sales here, okay, which is this is our dictionary that is keeping track of sales, and then access this shoe name. Okay, and then we'll add the quantity to what we already have. Okay, now if this is our first sale, we're just selling our first shoe, it means that we have nothing in our sales here. So what we are going to do is the whole quantity of the number of shoes that we're going to sell will become the value of this key or the shoe that we are selling. So run sales here and add the shoe name to the dictionary, and the value of this shoe name will be the whole quantity, just like that. Okay, so first, before we make a sale, we are checking if we have enough shoes. Okay, so if there is enough shoes, then we are going to make a sale here. Then we'll reduce the number of shoes that we have, and then we'll add the shoe that we have sold to the sales dictionary. Okay, we'll add the shoe name and the quantity, the number of shoes that we have sold. Now, if the requested shoes, okay, if the requested number of shoes is more than what we already have in our inventory, we want our code here to return something like note enough shoes available, something like that. Okay, so if somebody is trying to process, let's say they want to process a sale, and this sale is 5 shoes, and we only have like 3 shoes, we want our code to return not enough shoes are available. Okay, so this looks like it can process our sales. So let's try here to create an object of this class. Let's create a variable here called shop. Okay, and this will be the object of this class, and shoe shop. So we need to give this shoe shop a name. Let's call this sneaker center, something like that will be the name of the shop, and let's say it's located in Johannesburg, like that. So we've created a shop here. Now let's try to check how many shoes we have in our inventory here. So we'll use this shop here to access show inventory. Okay, if we run this code here, look, we get 0 here. This is because we have not added any shoes. If we check sales, okay, let's see how many shoes we have in sales. We say shop, sold shoes inventory here. We run this code. We get another empty dictionary because we haven't made any sale. Okay, so now let's try to add some shoes to our inventory. Let's say we've just received some Jordans. So we go to this shop and we say we use the add shoe method to add some shoes. So let's say we've received some Air Jordans, okay, Air Jordan, and we have received how many of these shoes? How many pairs of these shoes? This is Air Jordan, let's say 2, right? And how many of these shoes? Let's say we received 10 pairs of this sneaker right here. Now, let's run this code and see if our inventory is going to change. Run this code here. Now you can see that our inventory here, show inventory has changed. We now have 10 Jordans added to our dictionary. Okay, so let's use this method again. Let's say we've received another pair of Jordans. This time around we received 5 pairs. Okay, like that. Okay, what we want to see if this number of shoes is going to change from 10 here to 15. Okay, because we already have 10 Jordans in our inventory. Now we bring in 5. Let's see what happens. Let's run this code. So you can see here that we get 15. So the number of shoes has now changed from 10 to 15. So it means that the add shoe method here is working just fine. Now let's make some sales. Okay, so somebody wants 5 pairs of Jordans. So we are going to say shop. What is the name of this sell shoe method. Okay, so we are selling some Air Jordans here. So we have Air Jordan 2, and someone wants to buy, let's say, 5 pairs of Air Jordans. Okay, so remember in our stock here we have 15 and somebody wants to buy 5. So when we run this code, we expect this number here to drop to 10, and then we expect the number of sold shoes in our sales to become 5. Okay, so let's run this code here. So you can see that it's working just fine. So in our sales here, we now have five shoes sold, and in our inventory we have 10. Okay, so let's do this here. Let's add a string here so that we can tell these apart. So we'll say inventory here, inventory here, okay, inventory, and here we want to say shoes, or let's also call this sales, like that, so we can tell these apart, just like that. So now when we run this code here, okay, so we get inventory here, we have 10 shoes, and sales we have 5 shoes sold. Okay, now let's say somebody wants to buy, how many Jordans we have in our inventory? We have 10 Jordans. Now let's say somebody wants to buy 11. Okay, so this is more than what we have. So somebody wants to buy Air Jordans. So we only have 10 pairs left. So this person wants to buy, let's say they want to buy 11. Let's see what happens when we run this code. Okay, you can see that it doesn't change, meaning the transaction doesn't go through because we don't have enough shoes. Okay, so if we print this out, this should return the message that we don't have enough shoes. If we run this code here, okay, we get this shoe is out of stock. Let's go up here. Why do we get this shoe is out of stock? We want to sell. How many shoes we are trying to sell here? We're trying to sell 11 Jordans. Okay, and we have 10 Jordans in our. So why do we get these shoes out of stock? It's because we say Air Jordans 2 here when it's supposed to be just Air Jordan. So because we don't have Air Jordans here, okay, that's why we get this shoe is out of stock. Okay, because of a typo. So this is supposed to be Air Jordan 2, not Air Jordans. So now when we run this code again, so we get this message here, not enough shoes available, okay, because we're trying to buy, somebody's trying to buy 11 shoes and we only have 10 pairs here. So our code is actually working just fine. Now, let's add some sales value, because right now, when we make a sale here, we only get the name of the shoe and the number of shoes that have been sold. Now we want to get the sales value. We want to know how much money we've made from selling these shoes. Okay, so we are going to have to modify our sell shoe method here. So let's add price. Okay, let's add price to this method here. And now what we want to do is, if a shoe name is in sales, okay, we want to be able to add sales to our dictionary. So once we make a sale, we also add the dollar value of our sale. Okay, so we go to our dictionary here, and then we want to, let's create a key called sales. Okay, sales, and the sales we will have. So if we have already sold some Jordans, for example, and someone is buying some Jordans, what we want is, we want the amount to be added to the amount that we already have in our dictionary. So what we are going to do here is we are going to add the price and times quantity to the value that we already have. Okay, that is if we are selling a shoe that we have already sold before. So let's say we have $500 in our sales dictionary, and then we make a sale. Okay, let's say of $120. That 120 should be added to the 500 that we already have. Now, if we haven't made any sale here, what we want is to add the whole amount here. The whole sale value will be added as the value to the key. That will be the sales value to that shoe. So we'll add sales, and then the sales key here, the price times quantity. Okay, so this right here should be multiplication, not addition, like that. Okay, this is what is going to happen. So now here, let's come down here. So let's change this. So now we are selling some shoes. We've added some shoes here, and let's say now we sell some 5 Jordans, and each Jordan, let's say the price is $120, like that. Let's see if the sales is going to be added to our sales dictionary here. So if we run this code here, what we get, yes, we get sales here of $600. Okay, so 120 price per shoe multiplied by 5, we get $600. So let's say we make another sale here. Okay, let's say we make another sale, and this time we sell, let's say, 3 Jordans. Okay, let's see if this value here is going to change. Let's run this code again. Ooh, where did we get an error? Why did we get an error? So let's go up here. Let's check what's happening here. This is supposed to be sales. Line 24. This is supposed to be sales here, like that. All right. Now let's run this code again. Happens. All right. So we get 960 here. Okay. So it means that our code is working just fine. Okay. So now we get the number of shoes sold and the dollar amount of the shoes that we have sold. Now, here we have only added one type of sneaker. Let's see what happens if we add, let's say, another type of shoe. Okay, so let's add another type of shoe here. Add shoe, and then let's say we add some Yeezy. Okay, and let's say we've received 5 pairs of Yeezy. If we run this code, let's see what happens to our inventory here. So you can see that the Yeezy has been added to our inventory. Okay, and if we make a sale here, let's make a sale. Shop, supposed to be shop. Shop dot sell shoe. We sell some Yeezy here, and let's say we sold 3 shoes. Okay, so we have 5 shoes here. Now we're going to sell 3 shoes. We run this code. We need to add the price. So let's say the price is $200, like that. Now let's run this again. So now we get 3 shoes here, okay, that have been sold, and the number of shoes in our inventory has become 2, but then the sales value has become 600. Okay, so the other amount that we sold has disappeared. I think this is because we are actually using one key here. So we can only have, remember, in a dictionary you cannot have duplicate keys. So because we only have sales here, only one key can be in the dictionary. So the other key of the sales that we made of the Jordans has been overwritten by this new key here, the sales that we have made on the Yeezy. So I think what we can do here, we can actually add the name of the shoe to the sales key. Okay, so we can actually do something like plus shoe name, so that each key will be unique. So for example, if we sell Jordans, the sales will be sales Jordans and the sales value of those Jordans. And if we sell Yeezy, and then it will be sales, then Yeezy, and the sale amount of those shoes. So here as well, let's add shoe name, like that. Let's create some space like that. Okay, so let's see what happens when we run this code again. Okay, so now it looks like it works just fine. So when we go to our sales here, our sales dictionary, you can see that sales Air Jordan, we've sold $960. Okay, and for Yeezy, it's $600. So it looks like our code is working just fine. So you can see here that we can add shoes and we can also view shoes. Okay, so this is how you can create a simple tracker for a small business using classes. And I hope that you're going to take time to create your own. Okay, once you go through what we've done here, take some time, write your own code, and there's so many things that we can still add to this code here, but this is just a simple demonstration of something that you can create with classes.